Hey, this lesson is on how to convert from vertex to standard form. So, to warm us up, to get to that big idea, we're going to do a couple warm-ups, a few warm-ups. So the first warm-up is comparing and contrast between standard form and vertex form. So if you take a look at both of these right here, both of these two forms, standard form and vertex form, you need to take a look and see what's similar about the two forms. So to me, what's similar is that A and that A. And I think you've seen this before when we talked about it, but it's very important. Oopsies, wrong thing. This. So that A and this A are the same. So let's write that out. The A value. Okay, so that's the exact same thing. And it's also the same for factored form as well. That A is the same thing. It tells you which way it's opening, up or down, if it stretches or compresses. Okay, so you can tell straight from there. Now what's different is in standard form it has B and C, versus in vertex form they have H and K, which is the vertex. So that's why it's called vertex form. You can extract the vertex straight from there. And over here, B and C, if you remember, C is the y-intercept, and B is nothing yet. Okay, so that's what's different. And the other thing that's actually most important to identify for today is this. I'm having trouble with this. Okay, this squared term. Okay, they're the same. There's still two squared terms, so that makes them both quadratics. Okay, so they're both parabolas, but it's the placement, it's what is being squared in each case. In standard form, only the x is being squared. In vertex form, there's an x minus h all being squared. And that's something you have to, well, if you were to expand it up, you'd have to FOIL it out, right, and do distributive property. And all that stuff that we've been doing before. So, let's take a look at another example warm-up here. We're going to review the perfect square trinomials here. So, factor both of the relations below. So, right here, to factor this, we ask ourselves what two numbers multiply to 25 and add to 10. And again, to factor, we set up our two brackets. We ask ourselves here also what two numbers multiply to x, which is x and x. And as I said before, two numbers that multiply to 25 and add to 10 are both 5 and 5. And, oopsies, it's taking a while to get used to this. This can be rewritten as x plus 5 squared. So this is considered factored form, but I don't know if you recall, just from the last slide, this is actually taking it from standard form, and it's kind of a step to taking it to almost vertex form. You see how we have a binomial squared? That's what we have here, that binomial being squared here. That's the key thing here, which is what this perfect square trinomial is a key component of converting things into vertex form. Let's do another example here. Y equals, we have to factor this. So let's set up our two binomials here. Again, two things that multiply to x squared are x and x. Two numbers that multiply to 9 and add to 6 are both 3 and 3. And again, it's factored form, but again, it's also considered vertex form here, kind of, by having a binomial squared. All right. So there is a key thing here. Number 2, what is the relationship between the b term, the middle b term, and the last c term? So that's talking about this part right here, the middle term, the 10 and the 6, versus the last term, 25 and 9. Okay, so let's write that down here. 10 and 25, that's the middle b term, and that last c term, or 6 and 9, which is your middle term b, and last term c. What's the relationship between each of these, to go from b to c, okay? And you can see that the 5 here is kind of the key number that kind of connects both 10 and 25, right? How does 5 connect with 10? How does 5 connect with 25? How do you connect the 3 from 6 and the 9 there. So how do you go from 6 to 3 to 9? Is a better question I should be asking. How do you go from 10 to 5 to 25? So to do that, to start from B, to get to C, what we'd have to do is we take the 10, the B value, we're going to half it. You see how this is always half? 10 divided by 2 is always 5. And then we square it to get to the 25. So this is how one way of going from B to C. You half it and square it. And let's see if that works here. If we take half of 6, we get that term here. So 6 divided by 2, which is 3. And then we square it to get that final term there, which is 9. So to get the relationship between that B and that C term is that C is always going to be half of B and squared.